Well, we are done with the calculations. Okay, those were just simple calculations, mathematical calculations. Now we go to converting decimal integers, okay, fraction to binary, octal and hexadecimal, meaning we are doing the opposite. Okay, so the integer and fraction components of a decimal integer or other fraction number are both present, so they should always be present. So to convert a decimal integer or fraction to any other base, we need to do the following steps. So make sure, be with me in these steps. So the first step, use the instructions. Use the instructions. So mostly these instructions should be used in converting decimal integer to binary, octal, and hexadecimals to convert the desired base for the decimal integer component. Convert decimal fraction part to the desired base following the steps in converting decimal fraction to binary, octal, and hexadecimal numbers. To obtain integer or fraction, the integer and fraction parts of the required base must be joined. Okay, another example. I know you hate this part because of the calculations. Okay, but I mean, it's very simple. So let's try to convert 34.4674 from base 10 to base 2. Okay, so what do we have? So like we did previously, you divide 2 into 34. Okay, so dividing 2 into 34, we have 17, remainder 0. Then 2 into 17, 8, remainder 1. 2 into 4 is 2, remainder 0. Then 2 into 2 is giving us 1, remainder 0. 2 into 1 is 0, remainder 1. Therefore, the binary number 34.4674 to base 2, we now have 1, 0, 0, 0, 1, 0. So always you take from the bottom going up. Okay, then changing from a decimal to binary digits, for instance, using 0.4674, what do we have? 0.4674. Okay, so you multiply it by 2. For the whole number, we are dividing by 2, while for the decimal, you simply multiply. So 0.4674 times 2, what are we getting? We have 0.9348. Then multiply it again by 2, we have 1.8696. Multiplying it by 2, okay, we'll have something like more than 2, which is 3 point something. Now remember, the number 3 into base 2 is 1, remainder 1. So next, the value will now be 1.7392. Okay, we multiply it by 2, we'll have 1.4784. How? The same thing, 2 times 1.7, we'll have again 3 point something. So the number 3 in base 2 will have 1, 1, 1. Okay, so we just concentrate on the number 1. So next, multiplying it by 1.4784, we get 0.9568. Why? Because when you multiply 2 by 1.47, you have a number 2.8 something. But remember, 2 in base 2 is 0. That's the reason why we are having 0.9568. Multiplying it by 2, we have 1.8136. Okay, so therefore, the binary equivalent of 34.4674 is giving us 10010.01111 101.